Okay, in this video we are doing Calc BC Problem Set number 8. The problems and a playlist are in the description below. Let's take a look. Write down the nth degree Maclaurin polynomials that you have memorized. So Maclaurin is centered at 0. There are 4 that you should really have memorized. The first is sine. Sine is an odd function. You're going to get all the odd powers. Looks like this. It alternates, so it's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on. Pay attention to that factorial in the denominator. It's 2n plus 1 factorial, and that is an odd number. All right, then you'll have cosine. Cosine's an even function. You're going to have all the even powers starting at x to the 0, which is 1. Then you have minus x squared over 2 factorial plus x to the 4th over 4 factorial. Again, it's the factorial in the denominator that really triggers which one you're thinking about. You have to have memorized e to the x. E to the x just gets everything, and it does not alternate. So it's 1 plus x. It's really x to the 1st over 1 factorial if you want. Then x squared over 2 factorial, x cubed over 3 factorial, and so on. And then finally the geometric series, which is kind of my least favorite. So 1 over 1 minus x. I say that, it's just, it weirds me out that 1 over 1 minus x could be equal to this. It's just the sum of the powers of x. So 1 plus x squared plus ... up to x to the n. This is the only one that has a requirement. It's required that the absolute value of x be less than 1 for this to converge. Otherwise, it just diverges and doesn't give you anything kind of accurate. All right, let's take a look at the next problem. We want to find the third degree Taylor polynomial centered at 0, so that's a Maclaurin polynomial, for the function e to the x times sine of x. All right, so to do this, what I'm going to do is start off with just what e to the x is, right? So we memorized the series, the polynomial, or the series if you go to infinity, for e to the x, so that's going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial. So I've gone out to the cubed term because when I multiply by whatever sine is represented by, if there's a constant there, then when I multiply by x cubed, I'll still be at x cubed. So let's write down what sine is up to its third degree, or as close as we can get. So that's x minus x cubed over 3 factorial. Okay, so now I know that when I go through and I multiply term by term, the x cubed over 3 factorial that's in the e to the x doesn't have any constant term to multiply with, so that'll always give us something higher than the third degree, so it won't be a part of the third degree polynomial. Now what I'm going to do is take, I'm just going to multiply, right? So I'm going to take everything in purple and multiply it by 1. So that'll give me x minus x cubed over 3 factorial. I'm going to take everything in purple and multiply it by x. That gives me x squared minus x to the 4th over 3 factorial. I'm going to take everything in purple and multiply by x squared over 2 factorial. So that's going to give me x cubed over 2 factorial, and then minus x to the 5th over 2 factorial times 3 factorial. Okay, we only want third degree, so this term is gone and that term is gone. So now what I want to do is just kind of write down what we have, right? So we have e to the x times sine of x is approximately, the x is there, we have an x squared, and then for x cubed, we have 1 over 2 factorial minus 1 over 3 factorial, which is 1/2 minus 1/6. And then, if you want, you can simplify it to this. So that's how we can do it. We can take the polynomials that we're memorizing, and we can multiply them to get new polynomials for new functions, which is one of the key things that you want to be able to do. All right, let's take a look at the next problem. Given f of x is the sum from 0 to infinity, negative 1 to the n, x to the 2n over 3 to the n plus 1. We want to determine the interval on which f converges and then what it converges to on that interval, basically, for part B. I'm going to rewrite this. I pretty much always do this. I don't like anything to... I don't like any product to a power when I'm dealing with these. So I'm just going to rewrite this thing as first we're going to go negative 1 to the n, and then I'm going to write it as x squared to the n, and then I'm going to write the denominator is 3 times 3 to the n, because I'm trying to make it so that I have one thing to the nth power is basically my goal with this. I'm going to rewrite this again a little bit. So I'm going to pull out that 3 from the denominator, make it 1/3 on the outside. Then we have negative 1 to the n, we have x squared to the n, so that's negative x squared to the n, over 3 to the n, so we have negative x squared over 3 all to the n. So we rewrote it so that it looks like a much simpler thing, basically. Interval of convergence, I look at this and I say this is definitely geometric, and a geometric will always converge when the absolute value of r is less than 1. R in this case is negative x squared over 3, so we have the absolute value of negative x squared over 3 is less than 1, which means that just the absolute value of x squared is less than 3. X squared is always positive, so we can just drop the absolute value. So x squared is less than 3. If you think about that, that means that you are definitely between negative root 3 and root 3. The way that I usually actually solve that particular type of problem is I just think about the graph of x squared and the graph of y equals 3. And I think like, okay, where is x squared less than that? That's how I mentally deal with that problem. All right. For B, we want to find intervals of, on its interval of convergence, we want to rewrite f of x. So we just want to like use the sum of a geometric series, which we know is the first term over 1 minus the ratio. So since we rewrote this thing to look like this, I'm going to start with just that 1/3 and leave it out. It's going to be the first term. So take n equals 0 and sub it in. You get blah to the 0, which for these things is always going to give you 1, over 1 minus the ratio. The ratio is negative x squared over 3. And then we can simplify this a little bit, basically common denominator, and then like simplify the fraction. So I get 1/3 the quantity 3 over 3 plus x squared, and then the 3 and the 1/3 will actually cancel. So we'll get 1 over 3 plus x squared. And then the interval of convergence for that will just be negative root 3 to root 3. All right, let's take a look at the next one. We want to evaluate the limit as x approaches 0 of sine of 2x cubed minus 2x cubed over x to the 9th. So your first thought here might be, let's use L'Hopital's, but I've written in the problem, let's consider using series, because when you're first learning series, nobody wants to use them for anything. So what I'm going to do is I'm going to write a series for sine of 2x cubed, and I will replace sine of 2x cubed with that, and then I'll go from there. And also, I keep saying series. I really mean a polynomial. But I mean, I guess it's a series. It's just not an infinite series. All right, here goes. So sine of 2x cubed. So you want to take everything that you memorized for sine and replace all the x's with 2x cubed. So it's like sine of u would be u minus u cubed over 3 factorial plus u to the 5th over 5 factorial. Replace all the u's with 2x cubed, which gives us 2x cubed, and then minus the quantity 2x cubed over 3 factorial, and then plus the quantity 2x cubed to the 5th over 5 factorial. Okay, so now the limit that we're doing originally, I'm going to replace the sine of 2x cubed with that polynomial that I wrote. So I'm going to say this limit is now, I've replaced it, 2x cubed minus blah plus blah, and then minus 2x cubed. Notice the 2x cubed in the beginning and the minus 2x cubed, they're just going to cancel out. So I'm going to do that. So we get this. Also, 2 cubed is 8, and 2 to the 5th is 32, but like I'm just going to leave it as 2 to the 5th. So we have this. Now, every term that we see is going to get divided by x to the 9th, which means for that first term, the negative 8 over 6 times x to the 9th, we're just going to be left with negative 8 over 6, which is negative 4/3. For the next term, when we divide by x to the 9th, we're going to be left with an x to the 6th. So there's still an x there. So we get this. Now, if I let x equal 0, the x to the 6th becomes 0. All we're left with is negative 4/3. That's the answer to the problem. So we could have done sine out to like the 37th power, let's say. Everything after that, 2 to the 5th, x to the 15th over 5 factorial, everything after that, when we divide by x to the 9th, still going to have an x in it, still going to zero out. The answer to this problem is definitely negative 4/3. This is an example where series are way easier to use than L'Hopital's. L'Hopital's requires like a bunch of applications to get the answer. All right, let's do the final problem of this problem set. Determine the critical points of f of x equals quantity 4x minus 1 cubed, quantity 3x plus 1 squared. All right, this is like a very A-B question, but we got to pepper them in every once in a while to make sure that you're still up on that material. So f prime is going to be first. Derivative of the second is 6 times the quantity 3x plus 1 plus second, which is 3x plus 1 squared. Derivative of the first, just don't forget the chain rule. It's 3 and then times 4 by the chain rule. So 12 quantity 4x minus 1 squared. These problems are always factored by grouping. So you look for the common things. So you can take a 6 out, you can take a 4x minus 1 squared out, and you can take a 3x plus 1 out of both terms. So we will do that. And then what are we left with? Well, for the first part, we're left with a 4x minus 1. For the second part, because we only took out 6, we didn't take out 12, we still have a 2 and a 3x plus 1. Now what we do is just clean this up to get this, and then we're looking for the critical points. We don't have to classify them, thankfully, because this problem set is a little bit long. The critical points are just going to be 1/4, -1/3, and -1/10. All right, that's it for the problem set. I hope this was helpful, and good luck.